Okay, so picture this. It's late 2025. A team of astronomers decides to try something kind of crazy. They take a brand new AI, pointed at 3 decades of cosmic data from the Hubble Space Telescope, and basically tell it, go find something weird. Well, it did, and what it found has been shaking up the world of astronomy ever since. We're here to dig into exactly what happened.
So let's just start with the number that blows my mind every time I see it. 2.5 days. That's it. We're talking 60 hours of computing time. That's how long it took for this massive breakthrough to happen and for our map of cosmic oddities to get a major rewrite.
And just to put that speed into perspective, we're not talking about a small, curated data set here. In those 2.5 days, this AI chewed through nearly 100 million individual images from the Hubble Legacy Archive. A task that would have taken a single human researcher, well, probably their entire career, and then some.
So, here's our game plan for this deep dive. Think of it as our evidence board. First, we're going to look at the tool that made this all possible, how they basically hacked the Hubble archive. Then, we need to see if this thing is even legit, so we'll look at the known oddities it found. After that, we'll get into the really rare stuff it uncovered before we hit the absolute heart of the mystery, the 43 objects that nobody can explain. And we'll wrap up with the big debate. Are we seeing brand new physics, or are these just ghosts in the machine?
All right, let's meet the protagonist of our story. And no, it's not a person. It's an AI system that the European Space Agency built, and they called it AnomalyMatch. It was designed from the ground up for one very specific purpose: to learn how to spot things that just don't belong.
What's so cool is how AnomalyMatch's job just snowballed. It started with a really simple goal. Just find more of these super rare edge-on protoplanetary disks. They kind of look like cosmic hamburgers, which is awesome. But as it was training using this method called active learning, something interesting started happening. The researchers would confirm its findings, and in the process, the AI started flagging other weird stuff, things like merging galaxies and gravitational lenses. Its whole definition of odd just got wider and wider until the team just said, you know what, let's just unleash it on the whole archive. And bam! 60 hours later, the job was done.
Okay, so before we get to the truly bizarre stuff, the things that nobody can classify, we have to establish this AI's credentials, right? Did it actually work? And to do that, the researchers had to see if it could find the known unknowns. All the rare objects we already knew about, the ones we actually have names for.
And that brings us right back to its original mission. These things are called edge-on protoplanetary disks, and visually, they are just spectacular. These are literally the places where new planets are being born, but we're seeing them from the side. And that vantage point gives them this super distinct hamburger, or sometimes even a butterfly shape. Now, finding these is a really big deal because they are exceptionally rare. AnomalyMatch did its job. It found the ones we already knew were in the archive, but it didn't find any new ones. Now, this wasn't a failure of the AI, it was actually a success. It proved that there just weren't any more to be found in Hubble's data. Case closed on that one. Next up on the AI's checklist was the wonderfully named Jellyfish galaxy. And honestly, they look pretty much exactly how they sound. These beautiful galaxies with these long, trailing tendrils of gas and stars. The science behind these is just wild. A jellyfish galaxy is what you get when it's speeding through a super dense cluster of other galaxies and gets slammed by this thing called ram pressure. This intense pressure literally strips its gas away, creating those tentacles. So AnomalyMatch went looking, and it found 35 of them. And here's the really crucial part. 18 of those were brand new candidates. This was it. This was the first major proof that this AI could make genuinely new discoveries. Okay, so the AI has proven it's the real deal. It can find rare things. But now we get to the next level. This is where AnomalyMatch found something so ridiculously scarce, it puts its abilities in a completely different league. This wasn't just finding more of something we knew was out there. This was about finding something that had barely ever been seen at all.
They're called collisional ring galaxies, and they are the spectacular aftermath of one of the most precise and frankly violent events you can have in the cosmos. We're not talking about a little bump or a simple merger. This is something way, way more specific. Seriously, just imagine a cosmic bullseye. For one of these things to form, a smaller galaxy has to pass directly through the dead center of a bigger disc-shaped galaxy. That impact sends a shockwave roaring outwards, kind of like a stone dropped in a pond. And that shockwave triggers this massive, brilliant ring of new stars. The conditions have to be absolutely perfect, which makes them almost impossibly rare. And here it is. This is the punchline. After sifting through 100 million images, AnomalyMatch found exactly just two of these incredible structures in the entire archive. But here's the kicker. Neither of them had ever been documented in any scientific paper before. Humans had completely, totally missed them. The AI found them in 2.5 days.
So now we finally get to the real reason we're all here, the heart of this investigation. The AI proved it could find known rarities. It even found unknown examples of those rarities. But then it found something else. It found the things that didn't have a name.
This is the number that really matters. 43. After AnomalyMatch had sorted everything it could, all the mergers, the lenses, the jellyfish, the rings, it was left with this final, mysterious pile of 43 objects. It flagged them all as highly anomalous, but they were things that even seasoned astronomers couldn't fit into any existing box.
And this is where things get really, really weird. So first off, none of these 43 objects have ever shown up in a scientific paper. Ever. They are total unknowns. Their shapes, their morphologies, they don't match anything in the textbook. Some of them look a little bit like they're being hit by that ram pressure stripping, like a jellyfish galaxy. But here's the thing. They aren't in a dense cluster where that could happen. It's like seeing the wake from a boat, but there's no boat, and there's no water. The researchers just threw up their hands. They could not label them.
You know, this quote from the actual research paper is so telling. This isn't just hype for a headline. This is what real scientific caution looks like. The very people who live and breathe this stuff, who study galaxies for a living, looked at these 43 objects and basically said, we have no idea what these are, and we're not even going to try to guess. That is when you know you've stumbled onto a true mystery.
So, this brings us to the final, massive question that this whole discovery has cracked wide open. What are these 43 objects? Are we getting our first glimpse of something fundamentally new about how the universe works? Or are they just phantoms in the data? And this is the debate that's happening right now. On one side, you've got the digital ghosts theory. Maybe these are just really complicated image errors or glitches in the data processing. There's a known issue in the source catalog called shredding, which can actually chop up a single big galaxy into a bunch of overlapping pieces, creating weird-looking shapes. It's the skeptical view, and you have to consider it. But on the other hand, you have the possibility of new physics. Could these 43 objects be the very first evidence of a type of galactic interaction we've never even dreamed of? Or maybe some unknown cosmological phenomenon? That is the much more profound and, frankly, exciting possibility.
We just don't have the answer yet. But this entire story leaves us with one heck of a question to chew on. AnomalyMatch did all of this in 60 hours with data from just one telescope. We have new observatories like Euclid and the Rubin Observatory that are about to unleash a flood of data that will make the Hubble archive look tiny. So if this is what one AI found just hiding there in plain sight in only 2.5 days, what else is out there just waiting for us to ask the right questions?